Today we are going to talk about solving triangles using law of sines, but in a case where we might have 0, 1, or 2 solutions. In geometry, we learned that there were ways to know that triangles were congruent. These methods were side, 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 angle, side, angle, angle, side, angle, side, angle, RHL. In each of these cases, if I'm given information so that I have 3 sides and the triangle makes sense, meaning that any 2 sides added together has to be longer than the third side, I will have exactly one solution. And same in each of these cases. When I'm given 2 sides and the angle in between, I have exactly one solution. 2 angles and the side outside, one solution. 2 angles and the side between those 2 angles, one solution. And if I have a right triangle and I'm given the hypotenuse and the leg, I have one solution. However, if I'm given a case that has 2 sides and the angle outside of those 2 sides, meaning not included, like say that, I may have no solution, I might have one solution, or I might have 2 solutions. This occurs because of this situation here. If I have a side, and that's a fixed side length, and I have an angle measure, and that's fixed, and this side is fixed as well, you'll notice that it seems that I have exactly one solution. However, this side with the 2 tick marks could actually be turned inward so that I would then have another triangle over here. So in that case, I might have 2 solutions. And again, there could be 1 or there might be 0. So let's see how that happens. So I'm given this triangle. We're going to solve it. And first I'm going to draw it. And I'm going to label it A, B, C. A is 31 degrees. Side A is 10. Side B is 16. Of course, I don't know angle C, and I don't know side C. So I can tell that I can use the law of sines to solve this. I have an angle and the side opposite that angle, so I can use law of sines to solve for angle B. So sine of 31 over 10 equals sine of B over 16. So now I have to solve for sine of B by multiplying both sides by 16. And plugging that into my calculator, making sure my calculator is in degree mode, I find that that is equal to 0.8241. Now I'm going to find the reference angle. My reference angle is equal to inverse sine of what I just found. And that gives me 55.5 degrees. Now, sine is positive in the first and the second quadrant. So I may have a solution in the first quadrant, but at the same time, I might have a solution in the second quadrant with that same reference angle. So that angle, I have 2 choices for. 55.5 degrees in the first quadrant, or 180 minus 55.5 degrees in the second quadrant. And that is 124.5 degrees. So now I have to consider that my angle B might be 55.5, but at the same time, it might be 124.5. So now I have 2 potential triangles, and I'm just going to draw a picture of the second one. This is 31, this was 16, this is 10, And then again, angle B could be 124.5. Now, I can continue to solve using law of sines to find side C. First, I would have to find angle C by taking 180 and subtracting each of the other two sides. Press pause on your video, solve for angle C, 2 of them, and solve for side C, 2 of them. And when you're ready for the answers, press play again. So you can see here that I found 2 different angle C's, 93.5 and then 24.5. I used law of sines to solve for each of the corresponding sides. I should also just confirm that my smallest side is across from my smallest angle, largest side across from my largest angle. So here's my smallest angle. 10 is indeed my smallest side. Here is my largest angle, 93.5. 19.4 is my largest side. This one looks great. In the second triangle, this is my largest angle. 16 is my largest side. 24.5 is my smallest angle. 8.1 is my smallest side. Beautiful. 2 solutions to this problem. Here's another case. Let's draw a picture. I'm going to label it A, B, C. A is 23. B is 11. Angle A is 122. Obviously not drawn to scale. So again, using law of sines, I'm going to solve for angle B. So sine of 122 over 23 is equal to sine of B over 11. Solving for sine of B, I multiply both sides by 11. And I find that that is 0.4056. My reference angle then would be inverse sine of what I just found. Again, my calculator is in degree mode. So that is 23.9 degrees. Well, again, I could have an answer in the first quadrant or the second quadrant, both with that same reference angle. So B is either equal to 23.9 or B is equal to 180 minus 23.9, which is 156.1. However, when I look at it inside my triangle, there is no way that angle B could be 156.1 because these two angles would then sum to something over 180. Okay, so I'm going to have one solution here. I want you to solve for angle C and side C. Press pause on your video. When you're ready for the answer, press play again. So again, we have one solution, and I found angle C was 34.1. I used law of sines to find side C, 15.2. Here's another case. Let's check this one. Draw myself a triangle. So A is 45. Side A is B. Or side A is 4. Side B is 17. I'm going to use law of sines to solve for angle B. So sine of 45 over 4 is equal to sine of B over 17. Solving for sine of B, I see that sine of B would be 17 sine of 45, multiplying both sides by 17, over 4. And I find that's 3.005. Well, sine can never be over 1. So therefore, in this case, no solution exists. So, and if I forget that sine can't be over 1, when I plug it in my calculator, I do inverse sine of 3.05. My calculator says, what the heck are you doing? And it gives me an error. At that point, there's no solution. Now, there's one more case that I want you to see. I have a triangle with three sides given, and I can see that if I sum 5 and 10, that is more than 14, so I should have exactly one solution. Yesterday I told you it was really important to solve for the largest angle first using law of cosines. So we are going to do that. I'd like to solve for the largest angle, which would be A. It's across from side A, which happens to be 14. So A is 14, B is 5, C is 10. So using the law of cosines, I find that A squared, 14 squared equals 5 squared. We're using this formula. A squared equals B squared plus C squared minus 2BC cosine of A. So 14 squared equals 5 squared plus 10 squared minus 2 times 5 times 10 cosine of A. So I have to solve for cosine of A. That's 14 squared minus 5 squared minus 10 squared. Then I have to divide by -2, divide by 5, and divide by 10. So I find that cosine of A is -0.71. Now, cosine's negative in the second quadrant and also in the third quadrant. But in a triangle, I can only have an answer in the second quadrant. So to find A, I can do inverse cosine of -0.71. And that is 135.23. Now, by solving for the largest angle first, it is going to allow me to continue with the law of sines without concerning myself with the fact that I might have a situation where my angle is in the second quadrant. I've already found the obtuse angle. There can be no other obtuse angle, so I am safe to continue using law of sines. Of course, I could use law of cosines, and then I don't need to worry about any of that. So in this particular case, I would like you to finish this problem using the law of sines. Press pause on your video. When you're ready for the answer, press play again. So you can see I chose to solve for angle B using the law of sines, and I found that angle B was 14.57. I found angle C by taking 180 and subtracting the other two angles. So as you can see, law of sines, when you are solving for angles, you have to consider the ambiguous situation where you could have an angle in the first or the second quadrants. I'd like you to work on your lesson that is online, or I'm sorry, on your homework online. Have a great day.